Yesterday we talked about the indefinite integral, and we said that the difference between the infinite or the indefinite and the definite, that the indefinite is between negative and negative infinity and infinity interval, but indefinite it is between an it is have a definite integral. Like if you have a functions between negative like positive 3 and 7, in this interval you can write it, or you can write it as an integral from 3 to 7 of f of x. So this one, it's mean an definite integral. It's mean an integration of f of x from 3 to 7. And as we told you, we can find the definite integral by finding the, or by relate using the geometry to find the areas under the area, under the graph that I make it, or by using the techniques of differentiation and then evaluate. We talked here yesterday how can we sketch y equal to from interval 1 to 4, and we find the area of the shaded region. By that we found the integral. We solved this one, we solved this one, and we stopped here. For this one here, we have to evaluate. Here for this graph, as we see, they are already graphing. This is for x minus 1. If you want to draw it, you can plot many points here. And then when x is 0, y is negative 1. 0. When x is 1, it is, when x is 2, y is 1, 1, 1, negative 1. Then you sketch it like this, you will have this graph. Now, but here now you want to talk about this here from 0 to 2. You talked about this and this shaded area, that if you want to graph it big, you will find that this will be this sketch here. So for this one here, it's already sketched. I want now to find the integration from 0, from this point to 2. Now, the integration from 0 to 2 of x minus 1 is, here we have, as you see, we have from 0 to 1, we have two shapes, from 0 to 1 and from 1 to 2. So I'm talking about from 0 to 2. So we said it's from 0 to 1 and it's from 1 to 2. So if I have now from 0 to 2, if you have shape like this, or the graph that's sketched is like this as an example. Here we have 0 and here we have 2. For this one here, when you want to write the integration, you will write it as from 0 to 2 as one graph, and then you will find the area by the area of the triangle from 0 to 2. But here you have two shapes, and these two shapes, as you see here, we have these points. They have disconnected points. The first one, from 0 to 1, we have a shape, which we name it area 2. And from 1 to 2, we have an area, which is area 1. Then after that, so since they are not one shape, since they are two shapes, one from 0 to 1 and one from 1 to 2, I will say from 0 to 1 it is A2 and from 1 to 2 it is A1. Then now look at A2 here. This is a triangle. So let's find A2. A2, it's half. What is the length of the base?
1.
It's 3. It's 1. Sorry, 1 here. And the height, it's also 1 because it is, as I told you, when you graph it at 0x at point 0, 0 minus 1, it's negative 1 here. So the length also, the height also is 1. So what is the area, or what is A2? It's half. Let's find now A1, half. It is a triangle, so half. What is the length or the base? It is 1, which is here, 2 minus 1. And here at point 2, it is 1. Here we have point 1. So also the height is 1. So the A1 is also half. Then here we have, after we find the areas, A2. Now look at A2. A2, is it on the positive y-axis or on the negative y-axis?
Negative y-axis.
Negative
Is
y-axis.
it right? So that's why when I evaluate, I have to evaluate with negative half. Now look at A1. Is A1 in positive or negative y?
Positive.
Positive.
So I evaluated with positive. So the answer is 0. Is it clear?
Miss, can you repeat it from the beginning?
I will give you another example, but okay, let me do this one, then I will give you another example.
Okay.
Now, integration now from 0 to 1. Where from 0 to 1? Is it A2 or A1?
A1.
It is A2. From 0 to 1, it is A2. From 0 to 1, it is A2 here. So what is A2? What is the value of A2?
Half.
Negative half. Since it is on the negative y-axis, so it's negative half.
Miss, why half?
Here,
Oh, yeah, okay.
we found the area of triangle. We say it is half the base times the height. Negative because it's in the negative y-axis. Now let's try to do this example. This one here, as you see, it is the same but in different numbers. Here we have to find the integration from 2 to 7 of 2x minus 8. Integration of from 2 to 7 of 2x minus 8. So what did we have here? Look at from 2 to 7. It is a 1 or 2 shapes?
Two
Two
shapes.
shapes. So I will write it as from 2 to 4 and from 4 to 7. Is it right? The first shape is from 2 to 4 and the second one is from 4 to 7. Now let's find, or let's name this one with area 1 and this triangle here with A2. Now let's find A1, the area of the triangle between 2 to 4. Yeah, we all of us know that the area of triangle half the base times the height. What is the length of the base here?
2.
Here, it is 2. And the height?
4.
Yes, exactly, it is 4. So A1 here is 4. Let's find now A2, half. What is the length of the base?
4.
Why 4?
3.
7 minus
3.
4, 3. And the height?
6.
6, exactly. So A2 now is 9. Is it clear now, Shahid?
Yes.
Okay, now let's continue here. Come back to the integration. From 2 to 4, I'm talking about area 1. But is it positive or negative?
Negative.
Negative, exactly. Plus, from 4 to 7, it is A2. It's positive or negative?
Positive.
Positive. So let's now evaluate. Negative 4 plus 9. So the answer is 5. So the integration of 2x minus 8 from 2 to 7 is 5. Is it clear?
Yes, teacher.
Yes, teacher.
Do you understand it, Shahad?
Teacher,
Yes.
in the quiz you will
Yeah.
give us the drawing.
Yes, I will give it to you.
Okay.
Okay. Do you have any question here?
Teacher,
Yes.
we can solve this question without the graph.
Later on, I will give you another way using the techniques of differentiation. That's how can we solve this one without the graphing. But sometimes here, if you do it, if you look at it, you will see that's using the techniques of integration, you will solve it as one graph. But if you solve it by areas, you will find that's 2 graphs. So that's why here, if I ask you to do it by graphing, you must do it by graphing. And then finding the area.
Okay, teacher.
Okay. Charlotte, in the next week, when we give you the way, I will tell you why sometimes you have to go to use the area. If the question asks me to find it by the area, to find the integration by the area. Now let's talk about the properties of definite integral. In the domain of f, if a is in the domain, so the integration from a to a is 0. Like if you have f of x, like this, of x, from 1 to 1, I mean talking about this point 1, from 1 to 1. Look at the area here, from 1 to 1. I didn't move. So what's the area under this point here?
1.
No. Here,
0.
I'm talking about this one here. Okay, imagine that you have a small point here, and I want the integrate the area of this small point. You will tell me that it is the, imagine now it's like this. Yeah, what's this? It's like this here, and you have this point here. This is 1 at point 1. Okay, at point 1, and I'm asking you from 1 to 1. I'm talking about this area, the area here. At point 1, we found the area is 2 as an example, and at point 1, it is 2, which is 0. I mean that the integration of a point from A to A is 0. Like you didn't move, you only from 4 to 4. So you only move from 4 to 4. So what is the shaded area? Did you make any area? Did you make any shape if you didn't move? No. If you have from 1 to 2, and this is the shape, so yes, you make a region, so you will find its area. But if you are at 1 and you stay at 1, did you have any area now? Did you have any graph?
No.
Did you make any graph? If you are at point 1 and you stay at point 1?
No, teacher.
No.
No, you just make a point. So the area of this point is 0. That's why the integration from 7 to 7 for any function is 0. This is for the first one. And if f is integral on a to b, so we say that the function f of x from a to b can be written like this, which is equal negative the integration from b to a. I mean, if you want to write them from a to b, this is your integration of f of x from a to b, which is equal the negative of the interval. You have to make the opposite of, and you will change the order. From a to b, it will be from b to a, but you will change the sign. Like the integration of f of x from 2 to 4, okay, it's the same as the integration from 4 to 2, but with minus sign, with the opposite sign. How it can help you? As an example, if I told you that the integration from 2 to 4 for f of x is 9, and I told you, give me the integration from 4 to 2 of f of x, what you have to do? The given information for you is an integration from 2 to 4, but I asked you to give me the integration from 4 to 2. As you see here, they have the same numbers, but I changed the order. So I will say it's negative the integration of 2 to 4 of f of x. Or you can say it's negative 9. Is it clear?
Yes.
Yes, teacher.
Okay, let's do now another properties. If f and g are integrable on AB and c is a constant, then c, f and g, and f minus g are integrable on AB. And let's start now with the first one. If you have a constant times any function of f of x, and they are integrated from a to b, you have to put a constant outside the function as we did in the previous lesson. And then you have to find the integrate from a to b of f of x. So if you have a constant multiplied by an integrated function, just drop out the constant and then find the integration. The second one, if you have two functions that they are added, f of x plus g of x, like if you have f of x plus g of x from interval a to b, you have to just distribute the integral sign into f of x and into g of x with the numbers. And if you have a minus sign between them, you have to do the same. You just distribute the integral sign. Is it clear?
Yes, teacher.
Yes.
Yes.
Inshallah, when you talk, for example, I will tell you how can we distribute the integral, how can we put the constant outside, and so on. Now, let's talk about this one here. If f is integrable on a closed interval containing the 3 points a, b, and c, then as we said in the previous in this graph here, we need to distribute the areas. If you have this area here, A, C, and B, and I'm asking you to find the area from A to B of f of x. As you see, since we have two different shapes, so I would say it's from A to C and from C to B. Now, I'm sorry, miss. As I told you in the beginning of this semester, or for this year, the using of calculus is to find the areas of a complicated shape. For all the previous one, it's very easy. We see it is a triangle. We see it's quarter of a square. It is a trapezoid. It's a square. So it's very easy to me to find the area. And then after I found the area, I will say that this is the integration. But sometimes if we have a complicated shape like this one cannot say this is a triangle or this is a square or this is any shape. So what we have to do, we have to find the integration using the techniques of the next lesson. Then after I find the integration, I will say that this is the area of the shaded region. In the opposite way. If the shapes are clear, if the shapes are from shapes that we discussed in geometry, we found the area. Then after we find the area, we say that since this is the area, so this will be the integration. In the complicated shape, I will find the integration. Then I will say this will be the area. Is it clear?
Yes, teacher.
Now, let's now end with the last property. If f is integrable on AB and f of x is greater than x, so if you have f of x is greater than 0, so the integration of f of x would be also greater than 0. And if f of x is greater than g of x, so the integration of f of x from A to B will be greater than the integration of f of x from A to B. The most important properties that I want you to know it. This is very important. How can we divide the shape according to the, or divide the shaded region according to the connected points? Also, here we have to know how can we integrate the next tomorrow. Inshallah, I will give you more examples about them. And here, how can we divide the shaded region? Now, but before I stop here, let's have an this one here. Now, if you have, I want you now ask you questions like this. If you have a shape like this, and here we have shapes like this. Okay, here you have 0, 1, 2, and 3. Area 1, area 2, and area 3. And asked you to find the integration from 0 to 3. Okay, of f(x). Okay, so what you have to do? Look at these shapes here. How many shapes we have?
3.
3. So I will say from 0 to 1, and from 1 to 2, and from 2 to 3. Is it right?
Yes, teacher.
Now, from 0 to 1, is it positive or negative A1?
Negative.
Negative A1. And from 1 to 2,
Positive.
positive A2. Exactly. And from 2 to 3, negative A3. And then you will find the areas by geometry. Let's give you now another idea. If you have like what's this? Sorry, this. Like here now. If you have like zero, 1, and 2, and I'm asking you now to find the area or the integration from 0 to 2. What you have to do here? Can I say it's from 0 to 1 and 1 to 2, or you can say it's 1 to 2 from the beginning, from 0 to 2? Sorry, did I need to divide it?
No, teacher.
No, because we have only one shape, so no need to say that it's from 0 to 1, then from 1 to 2. I will say it's only from 1 to 2, which is area 1. Let's have another example like okay, like if you have one like this now, and then as an example like this. What's the integration will be? From 0 to 3. It will be divided from 0 to 2 and from 2 to 3. Is it right?
Yes, teacher.
Now from 0 to 2, it's negative or positive area?
Negative.
Negative A1. Sorry. I don't know where's the screen. It is negative plus negative because both of the two graphs are on the y-axis, on the negative y-axis. So I will say it's negative areas. Is it clear?
Yes.
Yes, teacher.
So now,
Yes,
since I will stop here today.